In this video, we're going to cover simplifying fractions, just one thing that people make a mistake on. So we want to try to correct that and give you a way to make sure you can do it right on your own. We need to cover two things. Okay, number one, a number divided by itself is 1. 10 over 10 is 1. 3 over 3 is 1. All right, number two, when we multiply two fractions together, you multiply the tops together and multiply the bottoms together. These are equal, so we could also go back the other way. 21 is 3 times 7, and 32 is 4 times 8. If we can go to the right, we can also go back to the left. That we need to remember. Now let's try a few examples. So, example number 1. We're going to simplify 6 over 10. Now, 6 over 10, remember, we could have had 2 times 3 and 2 times 5. But that could have come from multiplying these two fractions together. 2 over 2 times 3 over 5. Remember, multiply the tops together and get 6. Multiply the bottoms together and get 10. Okay, but that's the one thing we talked about. The way we multiply fractions, what we do, we can undo. And then a number divided by itself is 1, so we end up with 3/5. Okay, so properly simplifying this gives us 3/5. Let's look at another example. 6 plus 7 over 20 plus 6. If we simplify this correctly, we want to see what we're going to do. We need to add the tops first and add the bottoms. 6 plus 7 is 13. 20 plus 6 is 26. Now 13 is 13 times 1, and 26 is 13 times 2. We could have gotten that from 13 over 13 times 1/2. Remember, we get fractions and we multiply them together, top together and bottoms together, but we can also break it apart. If we divide out the 13, we get 1/2. Because the number divided by itself, as we talked about earlier, is 1. So this equals 1/2. Now, this is the correct way to do it. Let's look at a mistake that some people make. Some people think there's a 6 on top and bottom, so you can divide them out. They're thinking, oh, whenever you see something on the top and bottom, you divide them out. And that's misunderstanding the rule and engaging in poor thinking. You need to remember to know the identity of things. The rule is not whenever you have the same thing on the top and bottom, you cross them out. The rule is when you're dividing a number by itself, that divides to make 1. Then and only then can you divide. 6 is part of the whole number on top and bottom, so you cannot divide it out. And we can show that. If some people crossed it out and got 7 over 20, is that equal to 1/2 like it should be? Clearly not. That shows you that that's the wrong thing to do. Or, if some people crossed it out and remembered to put a 1, you get 8 over 21, which is still not equal to 1/2. This is still the wrong thing. Now, this is something you can do on your own to help you remember what's right and what's wrong. You can work it out by adding the tops together and see what you get. You can cross out and see what you get, and you can show yourself that they're not the same thing, so you know what's wrong and what's right. We got to factor something out of the whole entire top and the whole entire bottom to be able to get our correct answer. So now let's look at one more example. If we have 6 plus 16 over 27 plus 6, now remember, we're dividing some number by another. It's like we have these in parentheses and then the bottom in parentheses. It's grouped. So we have to add before we figure out what two numbers we're going to divide by. So we get 22 on top and 33 on bottom. You can stop the video and check that on your calculator if you need to. But 22 is 11 times 2 and 33 is 11 times 3. And as we said at the beginning, we could have gotten this by multiplying two fractions together. 22 on top, 33 on bottom. But as we also said, a number divided by itself is 1, so we end up with 2/3. Okay, so this should give us 2/3. Now let's look at a way some people do this incorrectly. Like before, they want to cross out this 6 that's the same on the top and bottom. But if we do that, we get 16 over 27, which is not 2/3. You can check it on your calculator if you need to. Find the decimal for each of these, and you see they are not the same thing. Or if someone remembers to put their 1 there, you still get 17 over 28, which again is not 2/3. So it's still wrong. You need to remember part of the top and part of the bottom cannot be canceled out. Let's try one more example. So the next example is algebraic. 6x plus 12 over 18 plus 6x. Let's see how to do this correctly first. Notice on top we could factor out a 6. 6 times x is 6x. 6 times 2 is 12. Factor out a 6 on bottom also. 6 times 3 is 18. 6 times x is 6x. But notice, and remember from what we said earlier, we could have gotten this by multiplying two fractions together. Multiply the tops together, multiply the bottoms together. That's number 2 of the things we talked about. Number 1, a number divided by itself is 1. So we should end up with x plus 2 over 3 plus x. Let's look at what you might end up with if you made a mistake that some people commonly make. Now, what some people do is to divide the top and bottom out. But you need to remember context. You can't just arbitrarily cross something out just because it's on the top and bottom. We can divide something out top and bottom only on the principle that something divided by itself is 1. But we don't have that. We've got part of something, part of a sum, and part of a sum on bottom. We can't divide out the parts. It's got to be a factor on the whole entire top and a factor on the whole entire bottom. So this would be 12/18, an invalid answer. You see it's not equal to the x plus 2 over 3 plus x, which is an x in it. 12 over 18, just in this example, it just happens to reduce to 2/3, but there's no x in it, so it's wrong. We can show you that in a second. If someone put a 1 there, they'd get 13 over 19. But that's still wrong. And we'll show you one thing you can do for yourself to see that that's not correct. Remember, in math, letters stand for numbers. As a human being, we name things. We apply names and letters. We do that in math also. That's just being human. Letters stand for numbers. So we could get a 2 and put it in place of x. We'd have 6 times 2 plus 12 over 18 times 6 plus 2. And that's exactly what we have here. I put a 2 in place of x. And if we work it out on top, 12 plus 12 is 24. 18 plus 12 is 30. If you factor a 6 out at the top and bottom, you get 4/5. And notice that's not equal to 12/18, which is 2/3. When you reduce it, you factor a 6 out of top and bottom, you get 2/3, not 4/5. But you get a 4/5 here. If you put a 2 in for x, it's clearly 4/5. So this is an easy way that you can check and see if you did something correctly. Just remember the principle that letters stand for numbers. Let's look at one more algebraic example. 3x squared plus 9x over 9x plus 15x to the third. Now on the top, we can factor out a 3x. Look at the 3 and the 9. They have a 3 in common, so we took that out. X squared and x, they have an x in common as a factor, so we took that out. And we can verify that we're correct by distributing and seeing if we get this. So 3x times x is 3x squared. 3x times 3 is 9x. So it's good. On the bottom, we factored out a 3x also. So let's verify that. 3x times 3 is your 9x, and 3x times 5x squared is 15x to the third. So it's good. Now, we could have gotten this product by multiplying these two separate fractions together. Because remember, with fractions, you multiply the tops together and you multiply the bottoms together. And you can look at that and see that's what we did. But a number divided by itself is 1, so we're left with x plus 3 over 3 plus 5x squared. That's the correct thing. So let's look at mistakes some people make. What some people do would be to divide out the 9x. But remember, that's a part of the top and a part of the bottom, so we cannot divide it out. If they would have done that, they'd have gotten 3x squared over 15x to the third. And we can show that's wrong by putting in, for example, a 1. If you put a 1 in for x up here, you could work it out. You get 3 plus 9 is 12. 9 plus 15 is 24. And 12 over 24 is 1/2. This does not come out to 1/2 when you put a 1 in for x. But this would. If we put a 1 in, we'd get 4 over 8, which reduces to 1/2. So make sure you're dividing something out that's in the whole entire top and the whole entire bottom. It's a factor of each, not like the 9x is here, a part of the top and a part of the bottom. Then you'll be doing this right. And so remember, we have to be able to factor something out of the whole entire top and the whole entire bottom, and two things divide to make one. Those are the two basic principles. Do not divide out part of the top and part of the bottom. It's wrong. Remember, factor something out of top and bottom. A number divided by itself is 1. Something else to remember is that we can put numbers in for letters to check to see if we're right or not, as we just did in these past two algebraic examples. So thank you for watching. Hope this helps.